Hi guys, in this video I'm going to talk about some questions about momentum and impulse. Okay, first we have momentum, a conservation of momentum question here. Okay, first thing that you need to do is draw a diagram, which is really important in doing mechanics questions. Okay, first we have two particles, which is P and Q. Okay, P has a mass of 0.5 kilogram and Q has a mass of m kilogram, and they are moving in opposite direction. Okay, you also can underline the question, which make it easier with the points. So they are moving in opposite direction, so in opposite direction along the same straight line on a smooth horizontal plane. Okay, smooth, which is no friction, and same straight line, which is in one dimension. So immediately before the collision, the speed of P is 4 meters per second and the speed of Q is 2 meters per second, and the magnitude of impulse exerted here on P by Q, which is the impulse exerted by Q on P, is equal to 4.2 Newton second. And we also need to know which direction is this impulse is. Okay, so since it's by Q on P, so which means it's by Q on P, so the impulse is actually towards the left. So I can draw a direction here towards the left. As a result of the collision, the direction of the motion P is reversed. So after it collides, P is reversed. In Q, okay, for Q, the question didn't say whether the ball Q will go to the left or right. So in here you can assume any direction you want. So you can assume it to be right first. Now we have all the informations. We can start to do question A. Okay, another thing is you need to indicate that everything towards the right is positive. Okay, so A, we need to find the speed of P immediately after the collision. Okay, here we have VP and VQ, and they need us to find VP. Okay, first you need to think which equation you should use, because we have three equations. These two equations is the most used equation in momentum and impulse questions. Okay, so first we need to think which equation we can use. So it's obvious that we can't use conservation of momentum because we have two unknowns here and we only have one equation, which is kind of impossible. But we actually can use this information, which is the impulse. So we know that JQP is equals to MP times VP minus UP. The impulse of QP is negative 4.2 because it's going to the left, so it's negative, so it's minus 4.2 equals to mass, which is 0.5 kilogram. And VP, since I know that the direction of VP is going to the left, so we put negative VP here and minus 4. We don't need to put the negative on 4 because it's going to the right, so it's remain positive. So now we arrange the equation, multiply both sides by 2, which is 8.4, and minus VP minus 4. So VP we know that is 4.4 meter per second. As you can see here, the 4.4 meter per second is positive. So does it mean it's going to the right? No, it's not, because before I start the calculation, I already put the negative inside, which means I already state that the final velocity of P will be negative, which means we'll be going to the left. Now find B. the speed of q immediately after the collision is 1 meter per second. So equals to 1 meter per second. So find the two possible values of m. Okay. In here, you need to think why there are two possible values of m. Because, as I said, the direction of q is not stated in the question. So it can be right, it can be going to the right or going to the left. So first, we need to consider the cases for going to the right. If q is going to the right, then vq is going to be positive. And in here, we're going to use conservation of momentum. And we can sub all the values in. 0.5 times 4 plus mq, which is m. Okay, it's going to the left, so we must put minus in it. And this is 0.5 times vp. vp, we have found it, which is 4.4. And it's going to the left, so it's minus 4.4 plus mq, which is m, times, okay, it's going to the right, so which means 1, positive 1. Now we can evaluate it. 2 minus 2m equals to minus 2.2 plus m. So it's equals to 4.2 equals to 3m. So m is equal to 1.4 kilogram. And now we need to consider another case, which is going to the left. When it's going to the left, what changes? If it's going to the left, this VQ will be negative. So in here, we can rewrite everything. Everything will be the same. It's just that we need to put a negative on the 1, which is here. Now, if we evaluate it, minus m, and it will become 4.2 equals to m. So we know that m is equal to 4.2 kilogram. The two possible values for m is 4.2 kilogram and 1.4 kilogram. This is about momentum as a vector when we have two components, which is x and y. In here, we have a ball which is mass 0.25 kilogram. Immediately before being struck, the ball is moving along a horizontal line AB, which is speed 30 meters per second. So U is equal to 30 meters per second. Since we know this is a vector question, so in here, I'm not going to put U equals to 30 only. I'm going to put U dash U. This dash means a vector. Dash U is equal to 30I. So immediately after being struck, the ball moves along the horizontal line with speed 40. So we note that V is equal to 40, but we need to resolve this angle towards the y-axis and the x-axis. Okay, if we're going into the angle, it will be cos 60I plus it's going out the 60 degree, so it's 40 sine 60j. Another way to look at this is you can draw a triangle. So we know this is 40, and this is the y component, and this is the x component, and we have 60 here. By using trigonometry, we can find y. So y is what? We use sine. Sine 60 is equal to y over 40. So y is equal to 40 sine 60. So for x, it's the same, which is cos 60 is equal to x over 40. So x is equal to 40 cos 60. But for me, the way I determine whether it's cos or sine is if it's going into the angle. What I mean going is if it resolves into the direction of the angle where the angle was there, it will be cos. If it's going out from the angle, it will be sine. Yeah, it depends on how you look at it. Everyone have their own method. If we evaluate cos 40 cos 60, it will be 20i plus 40 sine 60j, 20 square root 3j. Okay, now we have the initial and the final velocity. Okay, first we need to find it to three significant figure, which is kind of important, because if you didn't give the answer as three significant figure, you have maybe 1 mark deducted. So it's quite important, even though it's just 1 mark. Okay, first question, the magnitude of the impulse. So the magnitude is the change, mass time the change in velocity, and the velocity is a vector, so you need to put the dash line on it. Okay, it's equals to what's the mass? The mass is 0.25 times v, which is 20 and 20 square root 3 minus 30, 0. So it will be minus 10 and 20 square root 3. If we times 0.25, it will be equal to minus 2.5 and 20 times 0.25 and 5 square root 3. Okay, in here it says find the magnitude. So this is not magnitude, this is in vector form. So to find the magnitude, we can use the modulus, which is square root square both of this number plus 5 square root 3 square, which is 5 square root 13 over 2, and in three significant figure, which is 9.01 Newton second. So this is the magnitude. So if they need you to find the magnitude, you need to give them a number but not the direction. This is a vector, which is a direction, and this is a magnitude. This is the direction and this is the magnitude, which without the direction. Okay, number two, we need to find the size of angle that the direction of this impulse make with the original direction of motion of AB. So the original motion of the ball is going to the right? To find the direction of the impulse, we can draw a grid, maybe a cross, a graph, a simple graph, and then the x value is negative, so which means it's at the right side, and the y value is positive, so it's above the x-axis. So we know the direction will be going to the upper left. Here we estimated that the direction of the impulse will be going to the upper left. In this diagram, we know that the angle for this must be bigger than 90 degrees. So if our answer is below or equals to 90 degrees, we will definitely know that there are mistakes in it. Okay, so we know this is U and this is J, which is the impulse. Okay, to find the angle, we can use a formula, which is from further math. I think further math, vectors. which is cos theta is equal to 2 of this vector dotted and divided by magnitude of both of this vector. And another thing is, for example, if you have something like this, and then if you use this equation, you always find the angle between here where both of this vector is going out. So it's really important you don't make this kind of mistake, because some question they might need you to find this angle, so you might need to use maybe 180 minus this angle that you found. Yeah, it depends on the context and question, but most of them, yeah, will be in this kind of situation where 2 of the vector is going out and you need to find the angle between it. Okay, now we can sub the number in it. U is 30, 0, dotted with minus 2.5 and 5 square root 3 divided by the magnitude of J. The magnitude of J is 5 square root 13 over 2, and U, which is, because the magnitude of this will be 30, right? Because square root and 30 square will become 30, so it will remain the same. 30, so 30 times 2.5 is to minus 75 divided by 15 square root 30, 75 square root 13. If you eliminate 75, which is 106 in 3 significant figure. I hope you did learn something from it, and I hope I see you guys again. So see ya.